Right. So, try to obtain the answer as soon as possible. Right. So just hands up who's get the answers. Guys, here it is V equal root T over M. Right? Okay, let's go through the answers, right? So in this instance, 2 is now, I have told you that when obtaining the dimensions, keep in mind that you can neglect the numerical values and the constant with having numerical values, right? So in this equation, you can able to clearly identify that 2 is a numerical value and obviously 5 is a constant even though it is it is just a numerical value, right? So you know that 5 is equal to 3.14 or it can be mentioned as 22 over 7, right? So when you go through this equation, when you obtain the dimensions of t, right? So now we are going to obtain the dimensions of t. You can able to neglect the 2, 5, right? So just concern about the other physical quantities, right? So L represent the length. Length mean capital L, right? Over G mean acceleration. So you know that acceleration is the dimensions of acceleration. So when the L is cancelled, and when the t minus 2 come to the denominator, it's converted to positive 2. Then I have told you that root emphasize the half power, right? So instead of root, I'm using half power. Then the dimensions of t is equal to t. So that's mean this t represents the time, right? Okay. Then let's move on to the other one. In this instance, t represents the tension. And right, you should know that tension is a kind of a force, right? So in order to obtain the dimensions of tension, you have to think about the dimensions of force, right? So tension means it's a kind of a force, right? Then you might remember what is the relevant equation for the force, isn't it? Force mean mass into acceleration. Mass into acceleration, right? So mass mean capital M and the dimensions of acceleration is LT minus 2. Then this is the unit, the dimensions of force, right? So hence the dimensions of tension also should be equal to ML T minus 2, isn't it? Right. So in order to obtain the dimensions of M, here the M represent mass per unit length, isn't it? So I have told you that how to obtain this, how to obtain the relevant equation for this kind of definition. Guys, mass per unit length mean the equation should be mass should divide from the length. That is the meaning of mass per unit length. Per unit length also always come to the denominator positions, right? Then mass mean capital M, L mean capital L. This is the dimensions of simple length, right? So just substitute in order to obtain the dimensions of V. T mean M L T minus 2 over M L minus 1. And it should be my rows, right? So M is cancelled, then L come to the denominator, it's converted to L squared T minus 2, right? So as I mentioned earlier, this root sign represents the half power. Then this can be written as L square minus T minus 2, the half power, right? So this half power is relevant to this one and the T also. Then this can be written as L into the half T minus 2 into half, right? So the answer should be, this is the dimensions of V, it is LT minus 1, right? Okay, so this is the answer for dimensions of P, right? So just raise your hand if you get these answers. Right. So now up to now, we have discussed how to obtain the dimensions of a particular physical quantities, right? So from now onwards, I'm going to describe the importance of dimensions, right? So just put the topic as the importance of dimensions. Importance of dimensions. Importance of dimensions. So we also discuss about this topic in the unit lessons also, right? So in the unit lesson, we have discussed that there are two functions or two importance of discussing about the units, right? So what are they? Just try to recall the importance of units. There are two importance which is discussed under the unit, right? So what are the two importance of units? First one is we can able to determine the accuracy of an given equation by considering unit. The other thing is we can able to obtain the unit of a constant in a given equations, right? So these are the functions of unit, right? So both of these functions also discuss under the dimensions. So in dimensions, guys, keep in mind that there are three functions or three importance of having idea about the dimensions. But in the unit, we discuss only two. But when we come to the dimensions, we have to discuss three important points on dimension. First thing, the first two is similar to these two. That's mean we can able to determine the accuracy of an equation by considering dimensions, right? The second importance in dimension is we can able to obtain the dimension of a constant, right? We can able to obtain the dimension of a constant, right? And the third and the most important thing is in dimension, that is we can able to derive the equation, or that's on the other hand we can able to build up the equation by using dimensions, right? So this is the main function or the main importance under the dimensions, right? Okay, right. So let's put these three importance, right? So first one is determine the accuracy of an equation. Determine the accuracy of an equation in terms of dimension. That's the first importance, right? Just write in your textbook. Derive the accuracy of an equation in terms of dimensions, right? And the next function, number two, is the second function of the dimension is obtain the dimension of a constant. Obtain the dimension of a constant in an equation. Right. And the third function of dimension is, guys, just put this importance in red pen, right? Because this is that much of importance of dimension. The third function is derive the equation derive the equation by analyzing the dimensions. By analyzing the dimensions. By analyzing the dimensions. Right. So these are the importance of derived equation by analyzing the dimensions, right? So these are the functions of dimensions, guys, right? Okay. Now we are going to learn each of this topic separately, right? Okay. Just put a subtopic as the derive the accuracy of an equation in terms of dimension. Derive the accuracy of an equation. Derive the accuracy of an equation in terms of dimensions. Derive the accuracy of an equation in terms of dimensions. This is the top subtopic, right? Derive the accuracy of an equation in terms of dimensions, right? So this is the theory. Determine the accuracy. Determine the accuracy of an equation, right? So as we discussed in the units, the same principle applied here. That is, if the each term of an equation having same dimensions, if the each term of an equation having same dimension, then we consider that it is considered that equation is accurate in terms of dimensions. Guys, this is theory, right? So now you have idea how to obtain the terms of a given equation, isn't it? Right? So we have discussed how to obtain the terms, how to separate the terms in a given equation, isn't it? Right. So if the each term of an equation having same dimensions, that means it is considered that equation is accurate in terms of dimensions. On the other hand, we can able to consider the reverse of this theorem, that is, if the equation is accurate, if the equation is accurate, then we can able to come to a conclusion that each term having same dimensions, right? So this is the theory today, right? So just write down these two inside the box or inside the circle, right? So these are the theory which we need to describe under this topic, right? Just put those things in your textbook. Right. I think you have completed uh, this thing, right? Okay. Okay, right. Now take your tube, take this tube, that is physical quantities, right? So I have sent you 3 tubes. So out of these 3, just take out this the physical quantities unit tube, this one. And then turn the page of 8. Just turn the 8th page. Turn the page number 8. And just concern the 5th question, right? So in the 5th question, it is given that find the accuracy of an equation in terms of units. But even though now we are going to find the accuracy of the equation in terms of dimensions, right? So now you, from here onwards, you are doing this question in terms of dimensions, right? So just put the question number in your book, right? Then just write down the questions only for this question. Find the accuracy of the following equation in terms of dimensions, right? So from this question, you have to obtain the answers in terms of dimensions, right? Okay. So this is the 5th question in your quiz, right? So first of all, find the accuracy of the second equation, that is F equal M over R, right? So each term as defined, isn't it? So here F mean force, M mean mass, and R mean length, right? So first of all, so as this is the first question, I will tell you what are the procedures that you need to do, right? So first one, now this is the given equation, right? And just go through the equation and the meaning of this each symbols, right? So this is the first step, and then find out how many terms which is in this given equation, right? So if you look at this equation, you can able to find out that there are 2 terms, isn't it? Right? So what are the terms of this equation? The first one is F, and this is the M over R is the other term, right? So first of all, the first step is identify the identi, identify the identify the terms of the equation. So that's the first step, right? Then, so as we discussed, there are 2 terms in this equation, that is F and the first one is F, the other one is M over R, right? So the second step is you have to find the dimension of each term, right? So in this equation there are 2. Then find out the dimensions of F. Now F represent force, right? So what is the dimension of force? That is ml t minus 2. So that is, this is the dimensions of force, right? Then let's move on to the other one, that is m over r. So we represent the dimension word by putting a square brackets, right? So the dimensions of m over r mean m mean mass, that is capital M, r means L, because it is a length, no? So this is the dimensions of m over r, that is ml minus 1. Now, this is the dimensions of F and this is the dimensions of m over r. So you can able to clearly identify that there are two terms in this equation, but each term having a different dimension. So that's mean the conclusion is, therefore, equation is not accurate. Equation is not accurate or accuracy in terms of dimensions. In terms of dimensions. So that's mean you can able to find the accuracy of an equation in terms of unit or by using dimension. So both methods are correct, right? So so is that clear for you guys? Raise your hand if you're clear this enough. Okay. Just copy this one. Then after copying, just move to the sixth Roman number 6 question, right? Under the fifth question, that is R equals ut plus at square. R equal ut plus at square. Just find the accuracy of an equation. Just leave a react after obtain the answer, right? So let's move on to the discussion, right? So in this equation, you can able to find out that there are three terms, isn't it? The first one is R, second one is ut, the other one is at squared, right? So then you have identified that there are three terms in this equation. Then the next step is you have to find the dimensions of each term, right? So let's find out the dimensions of R. So this is the first term. Now R represent the distance, right? So that's mean the dimension should be L. Then the other term should be ut, product of u and t. U represent the velocity. If it is the velocity, it should be lt minus 1, and it should be multiplied by time. T mean time, then the dimensions of time is equal to t. So that is the dimensions of ut. On the other hand, the other term is at squared. Now a represents the acceleration. So the dimensions of acceleration is lt minus 2. and t represent the time, and we have to consider the t squared. Then it should be t squared, capital T squared. Then these cancel each other. Then the dimensions of AT squared is also L. Then you can able to find out that each term having a same dimension. Then the conclusion is equation is correct. Equation is correct or accurate in terms of dimension. In terms of dimensions. Right? Okay. Then move on to the seventh Roman number. That is f equal 6 pi theta r v. So now in this equation, this sign represents the coefficient of viscosity. Now I have told you that it's better to have an idea about the dimension and the units of coefficient of viscosity, right? So I have told you some small method or some small trick to obtain the accuracy of the dimension. Sorry, obtain the dimension of eta. How? What is the way? Then for that you have to know the units of this coefficient of viscosity. Guys, what is the unit of coefficient of viscosity? Just try to remember. That is kg m minus 1 is minus 1, isn't it? So by looking at the unit, you can able to figure out the dimensions of coefficient of viscosity. Now here, kg, kilogram represent the mass. Then what is the dimensions of mass? It should be m. M represents, simple M represent meters, right? So meters is measured the length. Therefore, this the dimensions of unit, the dimensions of M should be L minus 1. T represent the time, that is seconds. So second is used to measure the time. That's mean here it should be time. Then it should be T minus 1. So this is the way that we obtain the dimensions by looking at the units, right? Right. So just find out the accuracy of the equation. Just find out the accuracy of the equation. So if you finish the seventh one, right? So you have to do the question according to this order, right? Okay, let's go through the answer. Then in this equation, there are two terms. The first, this is the first one, and this is this whole thing is considered as a term, right? So let's find out the dimensions of F. That means force, no? the dimensions of force should be equal to mlt minus 2. Right, so this is the dimensions of force. Then let's find out the dimensions of 6 phi. This is pronounced as eta rv. Let's find out the dimensions of 6 phi eta rv. Right, so as I mentioned earlier, this 6 phi doesn't having a dimension because it is a numerical value. Then we have to consider only the eta r and v. Eta represents the coefficient of viscosity. Then this is the unit term. This is the dimensions of coefficient of viscosity, right? Then r mean distance. Sorry, is radius. Radius. The dimensions of radius should be L. V mean velocity. The dimensions of velocity should be equal to LT minus 1. So let's substitute, let's simplify this expression. Then we can able to cancel these two because here it is minus 1 and here it is plus 1. Then ML t minus 1 into t minus 1 mean t minus 2. Right. So then we can able to consider that this equation having a two terms and each term having a same dimensions. That's mean this equation is correct in terms of dimensions. In terms of dimensions, right? Okay. Let's move on to the fifth one. So then let's obtain the answer for the fifth one, right? So in the fifth question, you have given that U equal R squared G rho over eta, right? So now in this equation, you can able to identify that there are two terms in this equation, isn't it? So first one is U. So let's find out the dimensions of U. U represent the velocity. That's mean this is the unit the dimensions of velocity. Then let's move to the other one, that is R squared rho G over eta, right? So let's find out the dimensions of this term. Now R represent radius. So radius, then radius means a kind of a length and it should be L squared. Now rho, so this symbol represent the density, right? So then you have to find out what is the dimensions of density, right? So the dimensions of density mean M, L, L minus 3, right? Then it is G. G represent the gravitational acceleration or acceleration. Then it should be LT minus 2 over N. This sign represents the coefficient of viscosity. Guys, this is the dimensions of coefficient of viscosity. What is it? ML minus 1, T minus 1. So let's simplify this term. This M is cancelled each other. So when the L is moved to the nominator position, right? So just consider this one. Now L2 and L. So the result is L cube, right? L cube, and there's another L minus 3 in the nominator. So these two can be cancelled, right? So then you can, in the simplification, it's up to you, right? So then as a result, we can able to cancel these 3 at once. Then when this L minus come to the nominator, it's converting to plus 1, and this one come to the nominator, it's converting to plus 1, 2, and into T minus 2. So if we simplify further, you can able to obtain that the dimensions of this term is equal to LT minus 1. So that's mean this equation having a two terms, then each term having a same dimension. The conclusion is this equation is accurate or correct in terms of dimensions, right? So this is the conclusion. Okay, let's move on to the third one. Let's move on to the third subtopic, the sub question. So in the third question, you have given P equal YR over U, right? So P represents the pressure, Y represents Young modulus, right? So guys, keep in mind that I have told you that pressure and a Young modulus having a correlationship, right? So the dimensions, the units of the pressure equal to the same as the units of Young's modulus, right? Likewise, dimension of pressure is equal to the dimensions of Young's modulus, right? So keep in mind that the R represent length and U represent the velocity, right? So in this equation, there are two terms, isn't it? So let's find out the dimensions of P. Now P represent the pressure. Now if you forget the dimensions of pressure, just try to remember the relevant equation. Right. So pressure can be obtained by force over area. Right. So force mean MLT minus 2. The dimensions of area is equal to L squared. Right. So then if we further simplify it, then we can able to obtain that this is the dimensions of pressure, right? So this is the dimensions of pressure. Then let's find the dimensions of this whole term. Now, Y mean is Young's modulus. So, as I mentioned earlier, Young's modulus having the same dimensions as the pressure. Then it should be ML minus 1, T minus 2. R represent the length, so it should be L over U. U mean velocity. Then the dimension should be LT minus 1. So, if we further simplify this one, this L plus and this L minus is cancelled. So when these two come to the numerator, it's converting to ML minus 1, T minus 1. So that's mean these dimensions are not equal, isn't it? So that's mean we can able to consider that equation is not correct. Equation is not correct. Is not correct in terms of dimensions, right? So these are the way that we complete this kind of questions, right? So let's move on to the final one, that is 6-1. In this, in the fourth one, in the fourth question, you have given d over t pi r into the power 4 over 8 eta or 8 p over a, right? So you can able to figure out that in this equation, it is consists of two terms, isn't it? So this is the first one. This is the first one. So let's find out the dimensions of V over T. Now V represent the volume, isn't it? V represent the volume. So guys, what is the dimensions of volume? So try to remember what is the unit of dimension. What is the unit of volume? That is m cube, isn't it? This is the dimension. This is the unit of volume. Hence, this m represent the meters, right? So meters measure the length. That's mean the dimensions of volume should be equal to L cube, right? The dimensions of volume should be equal to L cube over T. That's mean L to the power 3T minus 1. So this is the dimensions of V over T. Let's move on to the other one, that is 5r into the power 4 p over 8 eta l. Right. So you can able to clearly understand that this equation consists of 5 and 8. So you don't need to worry about these the dimensions of 5 over 8. Then just neglect it. Then r represent the radius. That means it's a length. So it should be L into the power 4. P represent the pressure. So now you know that what is the dimensions of Alright. So there's a small mistake in this questions, right? Because the P is not defined. So guys, P represent the pressure, right? Okay. Now the dimensions of pressure should be ml minus 1, T minus 2 over dimensions of eta or n is equal to ml minus 1 T minus 1 into, right, now here L represent the length, so as the symbol the dimensions also is equal to L, right? So let's simplify this equation. This n can be cancelled and this L minus 1 and this L can be cancelled when the T's come to the denominator, and if we further simplify this of these two, L4 and L minus 1, so that's mean L into the power 3, T into the power 2. When the T minus 1 come to the denominator, it's converted into positive 1. Then this is the dimensions of this term. So that's mean you can able to figure out that both dimensions is correct enough, correct each other. Then we can able to mention that equation is correct. Don't forget about to write this sentence also in terms of dimensions, right? Okay. So this is the way that we obtain the accuracy of an equation in terms of dimensions, right? Okay. Now trace. Right. So these are the things that we need to know about how to determine the accuracy of an equation in terms of dimensions, right? So let's move on to the second importance of dimension. That is, just put the topic as obtain the dimensions of a constant Now we are going to describe how to obtain the dimensions of a constant in an equation, right? So as I mentioned earlier, guys, I will tell you what is the meaning of the constant later, right? So up to now, just keep in mind that this constant is a kind of a numerical value with having a dimension or not, right? So right. So the way that we obtain the dimensions of a constant is similar as the way that we obtain the unit of a constant, right? So both the method of the both things is similar, right? So you don't need to worry about the an extra method, right? So just is same as the which we done at the units, right? So let's find out this one. So let's take an example. Right. So let's find out that whether this is an equation, and I will define the term, the symbols of this equation. F represent the force, R represent the radius, G represent the acceleration. Then you have to find the dimensions of K, right? So K represent the constant, right? K represent the constant. So this method is similar as we discussed under the units. So the first step is you have to subject the constant, right? The first thing is you have to subject the constant. So in this equation, if equal k into the power kr into the power 4 over g, then if I subject the k, it should be fg over r into the power 4. Then the next step is, the second step is substitute the dimensions for the remaining physical quantities, right? Just substitute the dimensions for the remaining physical quantities except the k, right? So then F mean is force, that's mean in LT minus 2. G represent the acceleration, no? So then it should be LT minus 2 over R represent the radius, but we have to consider the power 4. Then L4. So this is the way that we substitute the dimension for this given expression. Then if we simplify this one, when the L4 come to the numerator, it's converted into minus 4. So on the numerator, it's have L power 2 and L into the power minus 4. Then this is the answer for the k. So this is the dimensions of k, right? So, now is this clear enough? Okay. Just copy those stuff in your textbook. Just copy those stuff. So after completing the copying of this example, let's move on to the sixth question in the tute on the page number 8, right? Sixth question in the tute, the page number 8 and the first Roman number. Here there's a equation of K over U P over R. Right. So guys, this is the question. Now in the sixth question, it is mentioned that find the units of the K in the following instances. But in this question, you have to find the dimensions of the K in the following instances, right? So the thing is now K represent the constant. Normally we use K to represent the constant. That's not the exact. That's not a rule. But normally we use K to represent a particular constant, right? But it can be changed according to the equation, but no generally, right? So then you have to find out the dimensions of K in this example, right? So K, P represent the pressure, represent the radius, and the U represent the velocity. Just go through the question and find out the dimensions of K. When you obtain the answer for the first one, then just move on to the second Roman number in this sixth question, right? Okay, just hurry up. Right. So let's find the dimensions of K. As I mentioned, first method, first step should be the subject the K. Then it should be UP over 4R. Just neglect the numerical values in obtaining the dimensions of K. U represent the velocity, that's in LT minus 1. P represent the pressure. P represent the pressure, that's mean ML minus 1, T minus 2. That's the dimensions of pressure. And just neglect the 4, then divide from the R. R mean radius, right? So then you know that you can able to cancel this L, and the answer should be the ML minus 1, T minus 3, right? So just leave a message if I made a mistake, right? So I can make mistakes. That's normal thing, right? So if it is a mistake, just let me know, right? Okay. In the second question, it is T over Y, T over Y equal for U. Okay. Now, now if the coefficient or if the constant is in the nominator or sorry denominator position, just make some cross multiplication. However, you have to subject the K, isn't it? Right. So if I go through the questions to subject the K, I made cross multiplication of these two in the diagonal patterns. That's mean K or T equal for U Y. Then if I subtract the K, then I can able to obtain that for U Y over T. Right. So then let's find the dimensions of A. Dimensions of A equal U mean velocity, that is LT minus 1. Y mean Young's modulus. So that's mean the dimensions of Young modulus is same as the pressure over T mean time. Then the answer should be the M. These two is cancelled. Then the answer should be the MT minus 4. Right? Guys, hands up those to obtain these answers. Okay. Just complete the fifth example in the 6 questions, right? Just find the dimensions of A in the fifth example. So let's go through the answer. Now here, this 2 root k over r equal u over f, right? So f represent the force, u represent the velocity, and r rate represent the radius, right? So as I mentioned earlier, let's subject the root k. It is equal to u r. If I make the cross multiplication, then u r over 2f, right? So just neglect the u. Then just find out the dimensions of k, root k, right? Find the dimensions of root k equal u mean velocity, lt minus 1, r mean radius, that is L, over f mean mlt minus 2, right? So in simplification, I can able to cancel these two. Then when the m is come to the m and the t minus 2 come to the denominator, is converted to m minus 1 L t minus 1 and t plus 2, right? That's mean this is the answer for the dimensions of root k. But even though we are asking to find the dimensions of k, not the root k, hence you have to consider the square of the in each side. Then root k into square mean k. Then the answer should be the m minus 2 L2 t into the power 2. So this is the dimensions of k, right? Okay, guys. Now let's turn the page number 10. Let's turn the page number 10, right? And just consider the 15th question. Let's come to the 15th question in page number 10, right? And try to obtain the dimensions in the second question, that is if equal k1u plus k2m. So guys, in this question, this equation consists of two constant, right? So then you have to obtain the dimensions of k1 as well as k2 separately, right? So in the previous question, we have go through the how to obtain the dimensions of a given constant. But when you come to the 15th question, you have to find the dimensions in both k1 and k2 constants, right? Okay. Now I have told you how to obtain the units in this kind of expression when we were discussing about the units, right? Just recall your memory and find out the dimensions of k1 and k2. Right. So you might remember that in this kind of equation, you can able to find out that there are three terms in this expressions, isn't it? Then, if this equation is correct, then the dimensions of f should be equal to dimensions of k1 u, and it is also equal to dimensions of k2 m. Guys, this is the theory, right? So you should have to identify, clarify these terms, right? And if this equation is correct one, then each term should having a same dimension, isn't it? Right. So now you have to find out the dimensions of k1 as well as the k2. So just first of all, let's concern these two. That's mean the dimensions of f should be equal to k1u. Dimensions of k1u, right? So if I subject the k1, that is k1 equal to f over u, right? So then let's substitute the relevant dimensions for this expression. F mean m lt minus 2 over u mean velocity, that is lt minus 1. So when these two cancelled and when the t minus 1 come to the denominator, it is converted into mt minus 1. So this is the dimensions of k1, right? So then let's consider these two equations. Oh, either you can able to equalize these two expressions also, but let's concern these two. So according to this one, the dimensions of f should be equal to dimensions of k2m, right? So if I subtract the k2, then k2 equal to f over m, right? So then substitute the relevant dimensions for f and m. F mean mlt minus 1, sorry, mlt minus 2. M mean mass, right? So what is the dimensions of mass? That is capital M. So if this cancelled, then this is the dimensions of K2. So likewise, the way that we obtain the dimension of two constant in a given equation, right? Okay, guys, let's go through the third question in this 15 question, right? Let's go through this third subtopic, third Roman number in the 15th question. Hurry up, guys. Right. So let's go through the answer. Now here, this is the given equation. P equal K1 over M minus K2 over L. Right. Guys, if you complete this one, just move on to the fourth questions, right? Just move on to the fourth question. Fourth Roman number, right? Okay. Right. So in this equation, you can able to identify that there are three terms, isn't it? So if it is a accurate equation, then dimensions of P, that means the dimensions of pressure, should be equal to dimensions of K1 over M, and it should be also equal to the dimensions of K2 over L. Right. Then in order to obtain the dimensions of K1, I'm using these two terms, isn't it? So then the dimensions of P should be equal to dimensions of K1 over M. So if I subject the K1, that is Pm, right? So P mean pressure. This is the dimensions of pressure. L minus 1, T minus 2. M mean mass, so it should be M, capital M. So the dimensions of M should be equal to this one. So this is the dimensions of K1, right? So in order to obtain the dimensions of K2, I'm using this one and these two. But you can also use equalize these two expressions too, right? It's up to you. If the equation is correct, then dimensions of P should be equal dimensions of K2 over L. Then if I subject the K2, it is equal to PL, right? P mean dimensions of pressure, L minus 1, T minus 2, L mean length, so it should be also L. Then this is the dimensions of K2. This is the dimensions of K2, that is MT minus 2. MT minus 2. So if I have made any mistake, just let me know, right? So I also made some mistake while doing the simplification. So just keep in touch, right? Okay, let's come to the fourth one. U equal. That's then just move on to the fifth one, right? Just move on to the fifth one after completing this fourth one. So in the fifth question, you have given that U equal M over root K1 minus P over K2, right? So according to theory, we have know that this equation consists of three terms. Then if the equation is correct one, dimensions of U should be equal to dimensions of M over root K1. And it is also equal to dimensions of P over K2. Right? So let's consider these two expressions. Then dimensions of U should be equal to M over root K1. So if I subject the root K1, then I make first multiplication, then root K1 into U equal M, then root K1 equal to M over U, right? So here the unit of the dimensions of K1, root K1 equal to M mean mass, U mean velocity, then dimensions of root K should be equal to M L minus 1 T1, right? But even though you have to ask to not the root K1 but for the K1, right? So then in order to obtain the dimensions of K1, it should be multiplied by, you have to consider the square of the both sides, right? So if you consider the square of the both side, then it should be equal to m squared L into the power minus 2 t into the power 2. Right, so this is the dimensions of K1. To obtain the dimensions of K2, I'm considering these two units, right? Then dimensions of U should be equal to dimensions of P over K2. So if I subject the K2, then I can able to obtain that K2 equal P over U, right? So let's substitute the dimensions for the each P and Q. P mean pressure. Pressure, if it is pressure, dimensions of pressure should be ml minus 1, T minus 2 over LT minus 1. Then when these two come to the denominator, it's converting to L minus 2 T minus 1. So this is the dimensions of K2, right? Right. So let's go through the answer for the fifth one, fifth common number. So in this equation, they have given that if root K1 equal to 6L over M plus 7K2 over M. Plus the students who have completed the fifth one, just move on to the first one, Roman number 1, right? Okay. Now, if this is the equation of, if it is an accurate equation, then we can able to consider that dimensions of if root K1 equal dimensions of 6L over M, and it should be equal to the dimensions of 7K2 over M, right? So let's consider two of them. So I'm considering these two. Then if K root K1 equal to 6L over M, right? So if I subject the root K1, then root K1 equal to 6L over M, right? So let's substitute the relevant dimensions for each sign symbols. Then dimensions of root K1 equal to, just neglect the 6. Here L mean length, that should be L. M mean mass, that is obviously capital M. Force mean MLT minus 1. So I can able to cancel these two, that is L. When these two come to the denominator, this is converting to M minus 2 T plus 2. So this is the dimensions of root K1. But even though we are asking to find the dimensions of K1, so then hence we have to consider the square of the both root square of the both side. Then the root sign is cancelled. Then the dimensions of K1 should be equal to m into the power minus 4 t into the power plus 4, right? So this is the dimensions of K1. So in order to obtain the K2, I'm selecting these two things, right? So if it is correct one, dimensions of 6L over M should be equal to 7K2 over M. Right. So if I subject the K2, then it should be 7LM, or sorry, 6LM over 7. Then you can able to easily cancel the neglect the numerical values, isn't it? Right. So let's substitute the values for L in L mean length, M mean mass over, in the denominator it's also mean mass. So these are cancelled. Then this is the dimensions of K2, that is L. Right? So this is the dimensions of K2. Right. achievement, right? Right. So in the let's go through the first Roman number in the 15th question. So this is the equation. This eta, or it can be pronounced as n. That's whatever 2k1 into p over r plus k2 over u, right? So I have told you that if you're given this kind of expression with including brackets, it's better to expand this equation. That is by multiplying the inside term from the 2k1. That is eta equal 2k1 p over r plus 2k1 k2 over u, right? So likewise, we can able to obtain the standard equation, right? So according to this equation, it is consists of three dimensions, sorry, three terms. Then if it is a correct one, dimensions of n or eta is equal dimensions of 2k 1p over r. Then it is also should be equal to dimensions of 2k1 k2 u over u, right? So let's consider these two. That's mean eta or n equal to 2k1 p over r. So if I subtract the k1, then it can be obtained as n r over 2p, right? So if I substitute the relevant dimensions, then the dimensions of eta should be n l minus 1 p minus 1 into r mean length, it should be l over p means pressure, that is ml minus 1 p minus 2, right? So if I simplify this further, I can able to cancel these 2 ml. Then k1 equal to t2 p minus 1 l. So the answer should be the lt. Dimensions of k1 should be equal to lt, right? So let's move on to the other one to obtain the dimensions of k2. Just concern these two. Then we can able to consider picking this as dimensions of 2k1 over p equal to r. Sorry, over r equal to 2k1 k2 over u. So I want to obtain the dimensions of k2. All right, so there's a if I subject the k2, then it can be written as 2k1 p u over 2k1 into r, right? So guys, you can be able to clearly obtain that. You can able to cancel these two, right? Then P mean pressure in T minus 1, T minus 2, ml minus 1, T minus 2. U mean velocity, that is LT minus 1 over R mean length, so it should be L. So if I further simplify this one, I am able to cancel it, and in L minus 1 T minus 3. So that is the unit dimensions of K2, right? Or guys, you can able to consider the terms inside the bracket, right? It is another method. So inside the bracket, it is consist of PR and K2 over U. So I have mentioned you that if there's a bracket and the terms inside the bracket can be equalized, right? So likewise, you can able to equalize the dimensions of P over R into the K2 over U, right? Okay. So today we have this now. We are discussing the importance of dimensions, right? So as I mentioned earlier, there are three importance of dimensions. That is, first one is um, So we have, I have told you that there are three importance of dimensions, right? And out of these three, we have completed the discussing of first two, right, with questions. And there's another remaining thing, that is the third one, and this is the most important one, right? So guys, so we will conduct the class on this Thursday, and don't miss this class on this Thursday, right? Because we are discussing, we will discuss one of the most important things in these dimensions, right? Because then if you miss the theoretical thing, so it will be a problem when obtaining the answer for the other questions, right? So don't miss the next day class, and you have to be very familiar and you have to be very keen knowledge regarding those stuffs and how to obtain the accuracy of an equation and how to obtain the dimension of a given constant, right? Okay. Now, so let's finish the today's class.